Hey everyone, I know I haven't been uploading for about a week now, and it was mostly because of the USACO contest and also because of homework. And speaking of homework, today we're going to be doing the USACO 2017 December contest silver problem, My Cal ate my homework. In this problem, you're given N questions where they're all graded by your teacher. And the way your teacher is going to calculate the final grade is to discard the question which you got the lowest grade on and averaging everything else. However, your pet cow Bessie has just eaten your answers to the first K questions. Your job is to output all the values of K, which could have earned you the maximum possible score. And without further ado, let's jump into the sample input. So in the sample input, I have here my N, which means we have 5 problems right now. And each of the numbers represent the score that you got on the problem. So let's just calculate the total score you will get using the algorithm that was described in the problem. And so that is just removing the smallest and averaging the rest. So the smallest here is 1, and we're going to discard 1 because it is the smallest. Then we're going to average the rest. So to average it, all we need to do is add them up and divide by the number of elements. So we're going to add all these up and divide by 4. So 3 plus 9 is 12, 12 plus 2 is 14, 14 plus 7 is 21. So we have 21 divided by 4, which will get you 5.25. 5.25 as your average score. Okay, so that is your average score if Bessie didn't eat any of your homework. Let's see what would happen if Bessie ate one of your homework. So if Bessie ate this homework right over here, so now let's still take out the smallest element, and that will be 1. So we'll take this out as well. So now all we're left with is 9, 2, and 7. So 9 plus 9 is 18. So we're going to do 18 divided by 3, which is 6. So after Bessie eats one problem, you're going to have now a score of 6. Okay, what about 3 problems? What about 2 problems? So if Bessie eats this first problem here and also eats this problem, we have to calculate the score over here. And to calculate it, all we need to do is remove the smallest element, which is 2. So after we remove it, we're going to average 7 and 9, which is going to give us a score of 8. Okay. So next one, Bessie is going to eat 9, and we're going to see the smallest right here is 2, and we're going to have a score of 7. And we're going to stop there, because if Bessie eats one more, then we can't really calculate the score of just one element. And so after trying all possible values of K, these are the scores we come up with, and we can see 8 is the best result, and 8 is achieved when we eat 2 homeworks, like so. How do we actually go about solving this problem? Well, the solution I just described is a brute force solution, and that is trying all of the possible values of K. And so every time you try a value of K, let's say if K is just 1, you have to cycle through the rest of the array and find the smallest element, which is right here, and you have to find the sum of all the other elements. And that is going to take, because trying K, there are n possible Ks, that's going to have a complexity of O of n squared. And in this case, when n is 10 to the 5th power, O of n squared is not going to work. And so we have to think of something else here. And the key to this problem is to think about the remaining problems. Every single time we are erasing something, the remaining problems is decreasing from here. It's getting eaten from the left. everything on the right over here is not touched. So instead of going from the left to the right, we can actually go from the right to the left. So we're gonna first do when Bessie eats most of the problems. When Bessie eats, let's say, 3 of the problems, because that is the most she can eat. So if Bessie eats 3 of the problems, all we have to do is cycle through these 2. So all we need to keep track of right now is the sum of everything and also the minimum element. So right now we can see the minimum element is 2. And the sum, 7 plus 2, is just going to be 9. So sum is going to be 9. And okay, so when we have the sum and the minimum, we can easily calculate the final score. All we need to do is subtract 2 from 9, where we get 7. That is basically the same as removing this 2 over here. Then we just divide it by how many elements minus 1, because we already removed 1. So 7 divided by 1 is just going to give us 7. And so that is going to be our final score. Okay. Now let's say Bessie didn't eat 3. Let's say Bessie only ate 2. Now we have added one more element to our array here. How do we deal with this? Well, the sum just increases by this element. So if we just add 9 here, we're going to have a sum of 18. Sum of 18. Oh, what is our minimum? Well, if this number right here is smaller than our minimum, then we could just replace minimum as this number. However, in this case, 9 is bigger than our minimum, so it's not going to be the minimum for the whole array over here. So our minimum is going to stay the same. We're going to do the exact same thing to this. All we're going to do is we're going to subtract the minimum from the sum. So 18 minus 2 is going to give us 16. Then we're going to divide by the number of elements minus 1, because we have already removed this 2 over here. So we're going to divide by 2. That gives us 8. So now our score is 8. Okay, let's do one more. We're gonna say Bessie didn't eat this. And if Bessie didn't eat this, we're kind of like adding this element to the current array we have. Okay, is it smaller than the minimum? Yes, it actually is smaller than the minimum. So this time we can actually replace the minimum with the current element here, which is 1. And so the minimum of the whole array over here is 1. And now what is the sum? Well, the sum is just going to increment by this element over here. So instead of 18, it's going to be 19. Okay, now we have the minimum and the sum. We can actually calculate the final score. All we need to do is subtract the minimum from the sum. We have 18 over here, divided by the number of elements minus 1. We have 4 here, minus 1 is 3. So we divide by 3, and that is going to give us 6. And we just keep doing this until we reach the end where we have nothing. As you can see, we have only used 2 variables, but we were able to find the total score of the current array without actually cycling through all of the array. Let's take a look at the code for this example. Okay, so in the code, I have my n over here, and we're going to read in the n first, and now we're going to read in the scores as a vector of integers. After we read in the score, we're going to keep track of our 2 variables here, as well as the maximum score that we can get, and also the result. So the maximum score is just going to be all the possible scores that we can get, but the maximum. And the result is going to keep track of the different values of k that can get us the maximum score. Okay. So as you can see, our total is just going to be the last element, and our minimum is just going to be the last element. Now we're going to cycle, and each time we cycle, all we do is we add the current score to the total, and we check if the score is smaller than the minimum. If it is, then replace the minimum with that score. Okay, now we're going to actually calculate the score. And to calculate the score, as I said before, we subtract the minimum from the total, then we divide everything by the amount of elements we have. In this case, it is n minus I minus 1. And notice how the score is not really an integer because we're dividing an integer by an integer. So it's not guaranteed to be an integer. And we have to use double over here. Now we're going to compare our score with the max score. And to compare two doubles, it is best to use this method, and I'm going to explain it right now. So basically, all we're doing is we're first subtracting the score and getting the absolute value. That's just going to get us the difference between these scores. Now, if the difference is less than, say, a small margin, in this case I define it as 0.001, then they're technically not the same, but they are close enough. So if they're close enough to being the same, then we're going to add our current I to the result, because the score we produced is the same as the max score. Or else, if the score is actually bigger than the max score, we're going to change the max score to the bigger score over here, and then we're going to clear everything in the result because it doesn't matter anymore, and we're going to add the current k to the result. That is it. That is all of our code. Then we just cycle backwards from the result because it wants our answer to be sorted, and print out the result. Sometimes you just have to solve the problem backwards. Hope you guys enjoyed this problem. Leave a like and subscribe, and also leave a comment for any problem that you want to see in the future, and I'll see you in the next USACO problem.